Okay, so in this question we're using partial fraction decomposition. As you recall, I can factor this out. This is very easy to factor and I can see it right away. It's gotta be, let me see, here we are. So this could be an x minus 6, x minus 7 factorization. So you have two distinct linear factors. And so you're going to set this up as a over x minus 6 plus b over x minus 7. And we're going to multiply the entire equation by x minus 6, x minus 7 on both sides. So obviously this is going to cancel and these are going to flip. So you're going to get x is equal to a parentheses x minus 7 plus b parentheses x minus 6, because the denominators and the numerators will cancel each other out respectively. We now work out the question where we distribute, so we get x equals ax minus 7a plus bx minus 6b. We combine the x terms together, so x equals, remember this is 1x, equals x parentheses a plus b, and the singles give us negative 7a minus 6b. Okay, and so that means that in this case I know that a plus b has to equal 1. I have a negative 7a minus 6b, and this has to equal 0. And so I can use substitution if I solve for b in terms of a. I can say that b is equal to 1 minus a. And if I plug this in to here, I'm going to get negative 7 times 1 minus a minus, I'm sorry, reverse that. I wrote the wrong one. So you're going to leave that alone. So the 7a, you're going to actually plug that in here. Erase that part there. I misspoke. Alright, so you're plugging this in for b there. So you have negative 7a minus 6 times 1 minus a, and that should equal 0. So negative 7a minus 6 plus 6a should equal 0. If I add the two a's together, the two a terms together, I get negative a minus 6 is equal to 0. So therefore a is equal to, looks like 6. If a is 6, there's something not correct here. Because technically, if I take out negative 1, I should end up, I should have a negative 6. What am I solving for? Yeah. No, this is incorrect. There's a math mistake up here somewhere. So let's go back. Because you're going to end up, you need to take out the negative 1 is what it is. Once you take out the negative 1, let me just explain it this way, because you have all the other steps correct. If you take out negative 1 here, or negative, this becomes a minus 7a, minus of 7a plus 6b, and that's equal to 0. And so that's how we end up with positive a, so it's actually positive, is going to yield us a negative 6. So this is kind of that situation. Okay, with the negative 6 on a, then I could plug that in. Negative 6 plus b, b has to be 7 to be true. So that answer choice should be a for that. Okay, and don't forget you have to write it over the distinct linear factors. Alright, for 32, more of the same, it looks like. Can you factor this further is the question. And the answer, I believe, is yes. I believe you have a situation where you have a trinomial, you can actually factor. So let's do that quickly. Let's see. I'm trying to erase a little bit so that you're not, they'll get confused. Also gives me a little time to dash back to that. Let's see. Erasing. Okay. So here we are. We're going to take out x squared from the first part, leaving me x plus 4. Is that fair? And if I take out a plus 3, am I not left with x plus 4? I am. That's good. So that means that I have a factor of x squared plus 3. That's one of my factors, and x plus 4. So given that this is a prime quadratic, I should be using ax plus b if I use that as a first term. Depends how you set it up. So I'm going to go ahead and I'm going to do that. So I'm going to say then 9x squared excuse me, plus 11x minus 5 over all of this gobbledygook, which is basically going to be our newly factored trinomial, is equal to ax plus b over x squared plus 3 plus c over x plus 4. Alright, and same thing applies. We're going to multiply the whole thing by that denominator. So we're multiplying by x squared plus 3, x plus 4 on this side, and the same thing on this side. And this is going to cancel with this, and these are going to swap, basically. So they're kind of going to cross multiply in a sense. So you end up with ax plus b times x plus 4 plus c times x squared plus 3. And this is equal to our numerator, which is 9x squared plus 11x minus 5. So now we FOIL, so we get ax squared plus 4ax plus bx plus b or 4b plus cx squared plus 3c. We want to group all like terms together, so in this case I'm going to take let's see here, I'm going to take the ax squared, where we go, I'm going to take the ax squared, I'm going to take the cx squared, I'm going to leave the x's, I'm going to bring together as well, so this becomes ax squared plus cx squared, which means that I could factor out x squared, and I know that a plus c has to equal 9, right? So I can just start thinking that way. As far as the x terms, I have this term, and that's it. So I do know that the x term, which is 11, so whatever I get here has to equal 11, and that's the 4a plus b has to equal 11, because you get the 4a plus b from here. And lastly, the single term, so 4b plus 3c has to equal -5. Okay. Let's see what we get. I'm trying to figure out what we could use. We could solve for a here and substitute it in here as a c term, and I can solve for b and substitute it in here as a c term. That's what I'm going to do. So in this case, A is equal to 9 minus C for this one. Alright, and for this one, I'm going to say that since I'm solving for B, I'm going to have minus 5 minus 3C divided by 4 is equal to B. And I know it's hideous, it's a fraction, God help us. But I'm going to substitute this in and I should be able to solve for C. Let's see. So you, no pun intended. So we have, for this one, 9 minus C, 4 times 9 minus C plus negative 5 minus 3C over 4. And all of this has to equal 11 based on. Okay, I'm running out of space. So now I have 11 is equal to 36 minus 4C plus the negative 5 minus 3C over 4. I want to get rid of that 4, so I'm going to multiply the whole thing. I know it sounds hideous, but I'm going to multiply all of that by 4, so I'm going to get 44 is equal to I believe 144. So basically I'm distributing, right? Minus 16C minus 5 minus 3C, and now I can solve easily because the 4 cancels. So 144 minus 5, so I have 44 equals 139 minus 19C, basically. And so yes, I'm going to subtract 139 on both sides. Yes, it's hideous, I know. 44 minus 139 is negative 95. And that's equal to negative 19C. So if you notice, the negatives will cancel. And I'm going to divide by 19. And I get C is equal to negative 5. Actually, C should just be positive 5, actually, because we divided by 2 positives. Duh. Alright, and so let's look at our answer choices. Oh, so we do have all of them with that. Okay, so we continue. Solve. So C is 5. Okay, so that means that in that case A is equal to 9 minus 5, which is 4. A is 4. And we have our B term. Our B term is where? Let's see. Well, we can substitute that. So B is equal to negative 5 minus 3 times 5 all over 4. Don't you get negative 20 for this? Divided by 4. Negative 20 divided by 4 should give us 5. And so B is equal to 5. So 4x plus 5 should be one of our factors over the plus C over. How did I write it? I have to go back. It's a lot of writing. So that C is, yeah, the C is the 5, and that should be over x plus 4. And this part should be written over the x squared plus 3. The only answer choice that matches that is this one. I know it's on reverse order, just swap them around. That was fun. I don't want to play anymore. We'll play outside with my dogs. You're on your own, kids. You're on your own. I quit. No kidding. I would never do that to you. Alright, I'm going to a new document. I am not erasing all of that. Alright. So we are on number 33. Number 33. Solve the system by substitution. That should not be difficult for you. So basically, you choose which one you want to use. X or Y, doesn't matter. So let's say we say x is equal to negative 17 minus y. And so what I'll do is I'll take this and I'll substitute it in here. So now I have minus 17 minus y times y is equal to 72. Notice that I'm going to end up with a trinomial, because when I distribute this, I'm going to end up with negative y squared minus 17y equal to 72. Okay? If I subtract 72 and bring it over, then I have negative y squared minus 17y minus 72 equal to 0. I can factor out the negative 1. If I do that, all the signs change. And now I can factor this as y plus 8, y plus 9, or negative 8, negative 9, right? And so for number 33, your answer choice should be B. Because when you solve for y, you're going or for the equation, you will have the two options. All right, so that's simple. The addition method, more of the same. I mean, if you want to see it, I guess I can do it. We're basically trying to cancel out all of the values that we can for 34. So the y's are already canceling. That's nice. The 4's are canceling. You're left with 2x squared plus 12x minus 32 is equal to 0. If I factor out the 2, I'm left with x squared plus 6x minus 16 equal to 0. Two numbers that will give me a negative 16 but a positive 6. I'm taking 8 and 2, so x plus 8, x minus 2. So one of my sets of factors should be, in this case, positive 2 and negative 8. The only one that gives me a positive 2, negative 8 combo is this one, so that's your answer choice. Okay, number 35. We want to solve the system using a matrix. Okay. I should put this on a separate piece of paper. This is another long one. Let me see if I can maybe get it completed inside the realm of how much space we have. Okay. So we start with our augmented matrix. So negative 4, negative 3, negative 1. That's our answer. So negative 11. Alright. We want 1, 7, negative 4, 11. Negative 6, 1, 1, negative 3. And so we want to start with a 1 here, because remember our ultimate goal is to have, would be nice if we could get it to this type of format, and so this would be answer choice X, Y, Z respectively, right? So the first thing I'm going to do is I'm going to swap row 1 and row 2, okay? And so that puts me at 1, 7, negative 4, 11, negative 4, negative 3, negative 1, negative 11, negative 6, 1, 1, negative 3. Alright, next thing I want to do is I want to zero out this part. So I'm going to do 4 times row 1 plus row 2. And I'm doing that right here. Alright, so if I do that, then I have 1, 7, negative 4, and then 11. This zeroes out because 4 times 1 is 4 plus the negative 4 is 0. I want that. Okay, 4 times 7 is 28. 28 minus 3 is 25. 4 times negative 4 is negative 16 plus negative 1 is negative 17. That's hideous. And 4 times negative 11, that's negative, 4 times 11, that's 44, minus 11, that's 32. And here you bring down your negative 6, 1, 1, negative 3. And we repeat the process. Here, what I'm going to do is I'm going to do 6 times row 1 plus row 2, because that's going to zero out the negative 6. So let me just change the font so I don't run out of spacing. I'll do that in blue. So the new row should be 0, right? Because 6 times 1 is 6 plus negative 6. I'm sorry, that should be a 3. Times negative 6 should be a 0. Okay. 6 times 7 is 42, and 42 plus 1 is 43. 6 times negative 4 is negative 24, plus 1, negative 23. And lastly, 6 times 11 is 66. 66 minus 3 is 63. Okay, so that's my new shape for the matrix. I'm going to erase up here because I don't want to run out of space. Sorry for the delay. This takes a little bit of time, you guys know that. Okay, so what we're going to do is we're going to continue zeroing out because we want to zero out the, actually I want a 25 here. I do want a 25 there. Or a 1 there. I want a 1 in that location, so what would be the best option? Because right now we have everything we need except for this. This has to be a 1. And I also need a 0 down here. I'm going to get a lot of fractions, which I'm not too thrilled about. Okay, so in this case, I could also, I'm going to go ahead, I'm just going to try it and see what happens. So up here, I'm going to re-express this 1, 7, negative 4, and obviously 11. I have a 0, 25, but I'm going to divide row 2 by 25 to get a 1 here. That's going to give me a hideous 17 over 25 and a hideous 33 over 25. And I'm going to leave it like that because I just don't care. Here's 0, 43, negative 23, and 63. Okay, so I'm good there. So 1, 0, 0. I would really like a 0 here. So at this point, I mean, I could focus on making that a 0. That would work. So if I did that part first, I could. Or I could try to zero out this part here as well, which I think I'd like to do that. Boy, this question's going to be a long question. Let's go with no, I think I'm going to go ahead and zero this out. So I'm going to go with this line being swapped out. So I'm going to actually erase this line because I'm going to work it down here. And there's other ways you can reach this answer, but basically the process is you're trying to zero this out. So, okay, so if I do if I do R2 times negative 43 plus R3, that would zero that out, because this is a 1 up here. The 0 doesn't matter because 0 times anything is 0, plus 0 times anything is still 0. So that line, that stays 0. This now gets zeroed out. And now I've got some hideous numbers coming my way. I've got a negative 17 divided by 25. Because that's my row 2. Times negative 43. And I'm going to add to that what I have in row 3, which is negative 23. And I've got a nasty fraction. Maybe there's a fraction. Oh, this is getting ugly, people. This is getting really bad. I can see where we can obtain the 1 for x. I think x should be 1. X is going to end up being a 1 we watch when all is said and done. I'm going to finish this question on paper, and I'm going to send you a copy of it, because there's not one way to do this, but as you continue, you can see this is taking forever, and I don't want to ruin the video. And these videos are very antsy about their time. Okay, so let me just skip that one, number 35. I will come back to 30. Remember, I still owe you number 30, which I'm going to do in 35, okay? Alright, let's do the quicker ones. Okay, so here this is notation. This is what element, where is the element? They're asking for A, row 3, 1, 2, 3, column 4. Row 3, column 4, and this is a 1, 2, 3, 4 by 1, 2, 3, 4, 5. So this is a 4 by 5 matrix, and the element that's located in this position is negative 5. Alright, for number 37, alright, so all you're saying there is, okay, if I have x is 10, that's your value, so 37x is 10, so it's either going to be this or this. These two you can eliminate. The other thing you know is that 8z is 40, so z has to be 5, so that works. Z is 5. This one says z is 40, so it has to be c then. That does not work. 38. Alright, and so basically we're doing a minus twice b, so if I have 1, negative 3, and 2, that's my a, minus twice b, that's going to put me at negative, or actually positive 2. Negative 1 times negative 2 is positive 2. Negative 2 times 3 is going to give you minus 6. And in this case, negative 2 times negative 2, positive 4. And so now we do our math, basic math. And so your answer choice should be D. You can see that 1 and 2, at this point we're at 1 and 2, that gives you 3, negative 3, negative 6, that's negative 9, 2 and 4, that's 6. Alright, for number 39, more of the same. You're basically using the matrix to solve, and so the first thing you want to solve is this. So this leaves you with negative x equals 3a minus b, but then you're going to divide by negative 1 on all three terms to get rid of the negative 1. So you get x equals b minus 3a. So b is 7, negative 3 zeros, negative 7, 4, 8, minus 3 times all of this. So 3 times this is 9, 3 times this is 12, this is negative 12, that's still 0. This is 27, negative 27, and this becomes positive 24. And so if I subtract backwards, you end up with, in this case, number 39, you should have 7 minus 9 is negative 2, and negative 7 minus 12 is negative 19, so I can ignore those two. This looks like it's the contender, because negative 3 minus 0 is negative 3, that's a positive, so it's not this one. Okay, and the last question that I'm doing in this recording is 40, and find the product Okay, and so in this case for number 40, your answer choice should be B. You remember how I showed you you have to first test to see if it works. So this is a 2 by 2 times a 2 by 3, and so yes, it does work. And what you want to do is you want to basically create a giant matrix. And because this has 3 rows, right, or 3 columns, my apologies, 3 columns, you're going to re-express this or reprint this 3 times. So -1, 3, 1, 4. -1, 3, and then 1, 4. And then we're going to take each of these respectively, and we are literally going to multiply this in the order that you see. So, and then you add their values. And so 1 times 0 plus 3 times 1, that's how we get the 3, so we know that that is correct. And then 7, -7 you obtain by the second row. Same thing, you take it, you flip it. You guys know the drill. So you're basically taking the matrix and you're substituting in the products of each of these and getting an addition for this. So for the bottom part, you end up with, what did I say for this one? You should end up with 4. So you get 4 times 1 and 0. So yeah, so this has to be it. Alright, just remember you're multiplying products, so you need to take, remember how I said to you, you take the row and you bend it so that now it goes this way. So if the row is going this way, you bend it and then you imprint it again. Multiply, multiply, multiply. Okay, I'm going to stop here and continue with 41.